everyone, in this video we are going to construct relative frequency histogram. In order that we can do that, let's take this first example right here. The data below shows the frequency distribution table of math test scores of 220 students with a mean of 31 and standard deviation of 10. Create a relative frequency histogram. So this is the table right here. So the first column is the interval, the second one is the frequency, and we need to determine the relative frequency. So the first step that we're going to do here is to determine the total. So if we add all of these, this would come out 220. So I'm just going to write 220 right here. And then in order to get the relative frequency, we are going to get the frequency divided by the total. So I can go ahead and set this up as 4 over 220. So again, that's the frequency divided by the total. So I need to use a calculator for this. And then the value for this, if I divide 4 divided by 220, would be 0.02. So I rounded this off to 2 decimal places. Again, it depends on the problem. If it's asking you for 3 decimal places, then you can add some more values right here, the one that you see on the calculator. But for this video, we're going to have values for relative frequency will be rounded off to 2 decimal places. So in order to get the next interval right here, that would be 23. So I will divide 23 divided by the total 220. And then again, I will have to use a calculator in order that I can determine the value for this. And that would be 0.10. Now I will do the rest of them here. Okay, so I've filled the column for relative frequency. Now, if I add all of these relative frequency that we have here, the total should be 1. So if you add all of these and it doesn't come out 1, be sure that you check your work and see which part you missed. So the relative frequency total would be 1. So from here, we're now ready to create the relative frequency histogram. Okay, so this side right here would be for relative frequency. And this horizontal line will be for the interval. Okay. What are we going to do next is we are going to look at the relative frequency that we have here. The highest value for relative frequency is 0.32. So then I can go ahead and have this up to 0.4. So I'm just going to take this as 0.1, 0.2, 0.3, and 0.4. Okay, for the interval that we have here, I'm gonna have, so the interval starts from, this is supposed to be 0. So it starts from 0 all the way to 70. So I can go ahead and say this is 0 right here. And so this would be 10, 20, 30, 40, 50, 60, and 70. So I've set up the histogram. What I'm going to do next now is I will have to graph this. So we start from the interval 0 to 10 is 0.02. So then I can go ahead and put that up here. So that's 0.02 would be, we can divide this as 0, half of that would be 0.05. So this is 0.01, 0.02, 0.03, 0.04, and 0.05. So 0.02 should be somewhere around here. So approximately right here. So I will label this as 0.02. So I'm going to color this box here. Okay, so let's move on to the next interval. From 10 to 20, it's going to be 0.10. So 0.10 is pretty much like this one right here. So 0.10, 0.20, 0.30, and 0.40. So 0.10 is this part right here. So I'm going to draw the box here. Okay, now let's move on to the next one. The next one here is from 20 to 30 is 0.23. So this one right here all the way up here is halfway between 0.20 and 0.30. So this is 0.25. So that means this is 0.21, 0.22, 0.23, 0.24, and 0.25. So I can go ahead and write 0.23 somewhere around here. So this is the box from 20 all the way to 30. Okay, let's move on to the next one here. From 30 to 40 is 0.32. So again, halfway between 30 and 40 is 0.35. So that's 31, 32, 33, 34, 35. So 0.32 should be, that's 31, 32. That should be somewhere around here. So I will draw the box. Okay, let's move on to the next one. That's from 40 to 50 is 0.22. So from 40 to 50, 0.22. So 20, 21, 22. That should be lower than 0.23. So that's somewhere around here. Okay, let's move on to the next one. From 50 to 60 is 0.09, so that's 0.5, 0.06, 0.07, 0.08, 0.09, and 0.10. So that should be somewhere around here. Okay, the last one here is from interval 60 to 70, that would be 0.02. So it's going to be the same thing as this. So I'm just going to put that up here. Okay, so this is our relative frequency histogram. Now let's solve problems that involves relative frequency histogram with this next slide that we have here. So we are going to use this relative frequency histogram that we did from the first slide in order that we can determine this problems right here. What percent of students scored above 30 and above? So if we say 30 and above means that we start from 30 and then we go all the way above to 30. So the numbers that we're adding would be these numbers on top of the boxes. Okay, so if we add all of these numbers that we have here, because that is 30 and above, then we can go ahead and get the value as 65. So that's 0.65, or pretty much this is 65%. So this means that with a given data, we would be able to see students that scored above 30 is actually 65%. Now let's have the ones that are below 40. Below 40 means from 40 we go down, anything below 40. So these numbers are the ones that we are adding. Okay, so I added all of these numbers because these are the values that are below 40. And so if I add this, this would give us 0.67, or pretty much 67% of students scored below 40. So that's what these values tell us. Now let's have the next one. The next one is between 20 and 50. So between 20 and then 50. So then we go ahead and add these three numbers here. Again, that's between 20 and 50. So the numbers are... So if we add all of these, 0.23, 0.32, and 0.22 would be 77%, or that's 0.77. So if we want to get the percentage for this, we just have to multiply this by 100. So that's how I got the 65. So 0.65 times 100 is 65. 0.67 times 100 is 0.67%, and 0.77 times 100 would be 77%. So what does this value tell us? 77% of the kids have scores between 20 to 50. The next one that we have here is outside 30 and 50. So 30 is right here. So we're looking for the ones that are outside of 30 and 50. In order that we can do that, we are going to consider only outside of 30 and 50. So that's the 30 and that's the 50 right there. So the ones we're not including the ones that are 30 and 50. So the numbers that we're adding are these ones right here, the ones that are not covered. Okay, I added everything. All the numbers are on top of the boxes that were not covered. And so that is 0.46. I multiply that by 100. And that gives me 46%. So what does this value tell me? That there are 46% of the students are actually had a score outside of 30 and 50. So that is based on this relative frequency histogram. Now let's move on to the next type of examples. Okay, so let's move on to this example right here. What percent of students scored 27? So as we can see here, if we look at the relative frequency histogram, 27 should be somewhere around here. So that is above 27, but this 0.23 started from 20, but then 27 is somewhere around here. So we can't just simply say that that is 0.23 and we add all the rest of these. So 0.27 is somewhere around there, but this 0.23 started from 20. So how do we solve problems that are actually not, it doesn't fall within the interval? So just like 27 and the 38 should be somewhere around here, but this 38, 0.32 is the value that started from 30 to 40, but we want only 38. So how do we find the value that we need to add if in cases that the values it doesn't fall within the interval? As you can see on this histogram that we have here, this histogram actually has a shape which we call as the normal curve. So if we draw a normal curve here, so this represents the normal curve. So then we go ahead and use the idea of normal curve in order that we can solve these problems right here. Before we can do that, let's have a review on the normal curve. The normal curve is sometimes called as the bell curve because the shape of this curve is like a bell. Now notice that the center of this normal curve is the mean, and this mean divides this curve into two parts. We have the left side and then we have the right side. Now again, notice that this left and right side are symmetric to each other. Symmetric means if I fold this curve on this side this way through the mean as the axis of symmetry, these sides are going to be on top of each other, so that we call these two sides are symmetric to each other. Now notice another important feature of this normal curve. These ends or these tails that we have here are asymptotic. Asymptotic means they are approaching closer and closer to this horizontal line, but they're not gonna touch it. They are asymptotic. So this is like the asymptote. This horizontal line is the asymptote. It's just gonna get closer and closer to it, but it's not gonna touch it. Now, another important feature for this normal curve is that it is divided into parts or segments. So from the mean, if we go down here, this line that I have created here is 1 standard deviation below the mean. Now, standard deviation is a number that tells us how deviated means how spread apart are the values. So this is 1 standard deviation below the mean, that's to the left. And so this other line right here is 2 standard deviation below the mean. Now we can add some more around here. That's the 3 standard deviation below the mean. On the other side, going up to the right, that's gonna be 1 standard deviation above the mean, and this is 2 standard deviation above the mean. So that's the normal curve right there. We always go back to this normal curve whenever we get a data that says the data is normally distributed or there's a normal distribution of the given data, then we use and go back to this idea of the normal curve. In order that we can solve this kind of problem, we are going to use 2 methods here. So the first method is using an applet. I will put the link of that applet in the description box below. The second method is using the graphing calculator. So let's take the applet first. So first thing that we're gonna do is we will put in the mean and the standard deviation on the correct boxes. And then since this first problem right here is asking us for the percentage above the mean, that means that we are going to type in 27 above, and then after we've typed in, we are going to hit recalculate at the bottom, and this gives us a value of 0.6554, or if we want to change this to percentage, this is 65.54%. Now let's move on to the one below. So I'm going to take the one that says below and I will put 38. And so I am going, so as you can see on the graph, you will see that we're looking for the area that is below the 38, the one that is shaded. So the value that we see, if we recalculate this gives us 0.758, or in percentage, this is 75.8%. Now let's move on to the between. So I'm going to take the between and then I'll type in 70 and 43. And so as you can see here, we're looking for the shaded area that is between 17 and 43. So if I hit recalculate, this would give So 80.42% of students score between 17 and 43. Now, if we look at outside 24 and 51, so this is how we use the applet to determine the values for each of these. Now, we are going to use the calculator. So using the calculator, there are special buttons that we need to use in order that we can determine these values. And you will see that the values that we get from the applet is the same as the values that we get from the calculator. So first, we are going to use this. I'm just going to put this up here. So what are we going to do is we are going to hit the second, then we hit the vars, and then we go down to 2. So I scroll down to 2 to get the normal CDF, and then hit enter. So I just followed all this, and this is gonna show up. That's normal CDF. So what are we gonna do next is we are going to type in the LB stands for the lower bound, UB stands for the upper bound, the mean, and the standard deviation. So what are we going to do is if we are supposed to draw this, the normal curve for above 27, this is how it's going to look. So this is the mean here was actually 31, and then the standard deviation is 10. So this one right here is 41, and then this one right here is 21, because remember it goes, we subtract the standard deviation and we add the standard deviation to the mean to get the numbers above and below the mean. So the lower bound that we're gonna have here, so if we say above 27, so that is somewhere around here, and this is the one that we are looking for, this area that we have right here. So the lower bound was actually 27, so I type in 27, and then the upper bound means where does it end? Remember, this goes to infinity. It doesn't end. It's asymptotic. It's not going to touch the line. So that means that we are going to use the number 1000. Let's just use 1000. So if it goes to infinity, just use the number 1000. So I will put a comma and then 1000 and then comma we have the mean. So the next one that we put in would be the mean, which is 31, and then comma, and then the standard deviation that we have here was 10. And so we close the parentheses and we get the same value, 0.554. So that is one way to that's how we use the calculator. Now another example that we have here below 38. So if I were to draw the normal curve here, so this is the normal curve, and this is 31 in the middle, 38 is somewhere here. So then that means I am interested to determine the area under this curve right here to the left of 38. So how do I determine the area for this? In order that I can do that, I will have the lower bound as negative 1000, because again, it went to infinity. So I will use negative 1000, and then the upper bound is 38. So what I would do here is that I will hit the second vars, then I will go to normal CDF, and then I'll type it in. That's negative 1000. And then comma, that's 38 as the upper bound. And then we have the mean is 31. And then the standard deviation is 10, close parentheses. The value that we have is 0.58, which is pretty much the same thing that we got from the applet. Next, for the next one right here, between 17 and 43. So if I were to draw this, the mean here is 31. So 17 is somewhere around here. And then 43 is somewhere around here. So then I am interested to determine the area between 17 and 43. So I will go back to the same step that we have here. So I've set it up, and so the value is actually the same as this, 0.8042. Again, it matches up with the applet that we used a while back. So either way you want to use, it's either the applet or the graphing calculator, they still give the same answer. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!